Hello, everyone. Let's see. Hopefully you can see. Are you seeing the Canvas page right now, or are you seeing my document camera?
Canvas page.
We're seeing the Canvas page.
Okay, good. Well, that's where we'll start. So, well, thanks for coming. I know it's we don't have any formal type of time that I can meet with you guys. So I hope this isn't too inconvenient, but I'd like to just try to connect just briefly today, and then we'll do this as needed every Thursday just to make sure everyone's doing okay in the lab and there's no questions. Of course, you can talk to me in office hours, but this will give me an opportunity to talk a little bit about the assignments that are coming up. So by now you've probably had a chance to look over the Canvas page and see a few of the things that are on there. The one I'm showing you is mine, so there's a little more detail to it because some of the stuff I've turned off so as to not overwhelm you. I'll activate stuff as we get further through the quarter, but you've probably looked at the syllabus just to give you an idea. My office hours are listed, and I've taught this lab probably about it's probably about the 21st time I've taught this lab, and we've done some changes on it over the years. Of course, the having it in virtual was never planned, so tried to do the best we can to, or I should say I have, tried to make it as tolerable as possible, but there will be some shortcomings to it just by the nature of you guys not being able to actually physically handle the equipment. So that said, I will try to go easy on you just because I understand it's stressful, and I know the lecture for this class is pretty challenging. So the lab hopefully won't be. And what I mean by that is not that it's going to be easy, just that I'm not going to try to kill you. So the first two assignments you're probably working on now are the Sig Figs and the Vernier caliper assignment. I want to say a couple things about the Vernier caliper assignment today, and then just to make sure we're clear with everything. And if you guys have questions, of course, speak up at any time. And then the second assignment is the review of the journal article. And I'm mentioning these because they're due next week. And I'll make sure you understand what's required of those. Now, by next week, you should have chosen your lab groups. And so if you have a lab group or a group of 4 people that you want to work with, please email them to me, and I'll put you guys in a group. If you don't, that's no big deal. I'll just assign people. So it's up to you. If you have a certain group of people you really want to work with, you can do that, or else you can just be randomly paired. Now, important thing is that you want to complete all the labs over the course of the quarter. That's a requirement for the lab, is that everything gets finished. And so if something comes up and you have to, there's some extraneous event going on, just talk to me, and we'll try to make sure that you can handle everything, get everything done. Another thing is, if you do end up in a group, because I do assign groups, and if for some reason your groups aren't working out the way you want them to, if one person's not pulling their weight, it's real important to talk to me about that as soon as you can. And I'll be the bad person. I'll be the one to intercede on it, because the last thing I want is for 1 or 2 people to do all the work for these few lab reports that you have that are somewhat involved. And if everyone does their share, then they're not so bad. But if one person has to do it, or 2, then it can be overwhelming. As far as the course pack goes, as I mentioned in my announcement, that all the details of the course pack are posted on Professor Thorncroft's lecture Canvas page. So anything you need there, including the lab experiments, are there. Some of it I'll pull over and put on in my modules, but if I reference anything, that's where you'll find it. Okay. So let me, I want to mention, before we talk about the different assignments, I do want to talk about this upcoming one with the executive memo. So this one is something I've started doing for virtual because there's labs we just can't do virtual. And so to give you something else that's worthy, I think, is this assignment. And so in this case, what I want you guys to do is, and if you haven't read it already, I want you to pick a product that it has the potential for a class action lawsuit. And so I don't expect you to be lawyers when doing this, but I want you to think about things that have been, you've either read about, seen in the news, seen online that have been substantial failures and due to company incompetence or outright malice have produced a product that is inferior either in quality or is downright dangerous. So one example that I have is the MacBook. And if any of you have a MacBook with a butterfly keyboard that has come out between, I think the first keyboard came out in 2015 with the butterfly, and they recently switched back to the scissor keyboard. And I know all the details of this because I actually am working on that lawsuit. So part of my universe besides teaching at Poly is working as a consultant. And up until recently, I couldn't say anything about this case because it was all in the wraps. But now it's public knowledge that Apple is being sued, and the firm I'm working with just got class certification. So that means that they can go after them as a class action lawsuit in 7 states currently for the butterfly keyboard being essentially a dog and completely not really up to par as it should be. So a lot of details to that, but it's been an interesting case so far working on, and I've taken apart probably over a dozen MacBooks to look at the different keyboards and essentially found all the gory details about them. But that's a topic for another day. So that's the one topic I don't want you to talk about. So don't pick the MacBooks, but anything else is fair game. And so when picking one of these, I would just pick something that interests you. And it doesn't necessarily have to be, and nor should it be, a current class action. If it is, that's okay. But if it's just something that you think was poorly designed or needs to be addressed, then be creative. And that's part of the way I grade this assignment. And so the parameters of the assignments are listed below. And in addition, there's also a grading rubric that tells you how I score it. So that is also on the module page. If you look at under memo down here, it'll tell you grading rubric. And so this is how I'll read it, and this is how I'll grade it. So if you get a score, usually no one gets below a 30. So but this will give you an idea of what to strive for if you want to get a 50 out of 50 versus a 45 or a 40. All right. So I think have fun with that assignment. I know writing is like pulling teeth and can seem like pulling teeth, but I can't emphasize enough how important it is. And having worked with dozens of lawyers and done literally hundreds of projects with different companies over the last 25 years, that's probably the single most important part of when I interact with the client is my report and how I present their information to them. And if you can do that effectively, then it not only does it increase your paycheck, but it also increases the respect that they have for you. So, and I know it sounds preachy and I'm not trying to be, but just try to keep that in the back of your head that communication is key, and it'll actually be more important than your technical knowledge if you can effectively communicate to your peers and to your management. Okay, enough of that. So that's that assignment. Now, as far as the Sig Fig assignments go, everything about Sig Fig you should be able to read those pages that are referenced in the course pack, and it should tell you how to do it. The way I have it set up, as you've seen, is you'll answer the questions and then you'll input them into Canvas. Now, if your answers come back wrong in Canvas and you know they're right, don't fret, because I unfortunately, canvas is a little quirky, so I'll have to go through and I'm going to end up hand grading all of them anyway. So having them in canvas turned out not to be much of a time saver for me, but that's not your problem. I'll go back and review them. And if there are errors, then of course you want to know what the errors are. So, but this is the assignment's only 25 points, so it's not like a breaker of your grade. It's more or less just to get some practice and make sure you understand it. Now, the Vernier caliper assignment, that one's just reading Vernier calipers. I think once you look at the tutorial, or if you've done it before, it's fairly simple. The only thing is that you probably may or may not have been exposed to is the concept of the zero error. And so what I wanted to show you real quick with zero error was this. And can you see my document camera now? Let's see.
Yes.
Okay, good. So with the document camera, what you should see is this. So with the Vernier, when you look at a Vernier caliper, or if you look at the assignment that I've given you, think of the bottom row as the fixed row. So this is your reference point, so to speak. So kind of think of that as marks on a track. So I'm using the analogy of running a race to help explain this. So this would be like, say, this would be your starting line 0. And then this would be, say, after you've gone, 50 meters, 100 meters, whatever. So just imagine you're running in a straight line. So the top part, the sliding part, is you running on the race, or the actual caliper jaws opening. So it makes sense that when the jaws, if it's a perfect caliper, then the 0 up here should line up with the 0 here. So it should just be a 0 just like that. That would be perfect, because that means you're starting at the start line, and whatever you measure beyond that is the actual measurement. Now, over time, calipers get dropped, they get abused, and so sometimes what will happen is when you close the jaws completely, you get this situation where the 0 is either ahead of the starting line or behind the starting line. And so that's called the 0 error. Now, if you have 0 error to the left of it, then think of it as you're actually starting behind the starting line. And so on the problems that you have where the 0 on the top is to the left of the 0 on the bottom, that means that instead of starting at the starting line, maybe you started 5 meters behind it. So if that's the case, when you run out here, or you move the caliper over to measure something out here, you've measured all that distance plus whatever distances you start. So what your final answer is your reading plus your reading plus the 0 error. Okay. And so that's that part. Now that's pretty easy, because generally the 0 error will be easy to measure. The line will line up and you'll say, oh, it's plus 3 or 300ths or 3,000ths, whatever the mark is. And so you just add it to it. Now the 0 error when it's negative is a little different. In that case, that means that your starting line is back here, but now instead of starting behind the starting line, you're starting in front of it. So maybe you've 5 meters ahead of the starting line, and now you're running your race. So when you get to the end, instead of running 100, you've only ran 95 meters. So you need to subtract off that distance here in order to compensate for the distance that it's actually ahead. And so you actually added, you have extra distance. So now you have your reading minus 0 error. Okay. Now when
isn't it the opposite?
Am I doing it backwards?
I think it's opposite.
Yeah.
I was Yeah, your zero, so your zero, if it starts ahead, yes, so if this is, so in this case, if this is this here, right, this is your starting line, correct? And this is your caliper that moves, right? So does it make sense that if you, does it make sense that if instead of starting at zero, you're starting out here? So what you actually measure is going to be bigger than it should be. That's why this is, see, it's not backwards, because if this is your 0 point, then think of it as, so if you look at the problems in it, and I mean, if you guys already understand, that's fine. I'm not trying to confuse you. But if you look at, for example, one of the problems where if 0 is over here and this is your fixed position, then really what you're saying is you have an additional 0.06 centimeters. And so you've essentially, in order to get the correct answer, yeah, you know you're correct. I apologize. I think my analogy is correct, but what I did, and I'm sorry about that, is this should be negative and plus. So yeah, you subtract this off, you add that. There we go. I think this analogy is correct, and maybe I made it overly complicated and I didn't need to. But if it's still the idea though, is if you start behind the starting line, you still go farther. And if you start ahead of this line, you still go more. But so I would say that and part of the reason I brought this up was I wanted to point out the fact that if you have these, and depending on where they line up, when you have the negative, so for example, if you have 0 and let's say it's like this, not 0 there. And so you look and you find where it lines up. And this is one of the examples. If this lines up here, and let's say that that's the 7, if that's 7 that lines up on that, when it looks like this, then what you effectively have is a negative 0.03. And so unlike the difference is, unlike with the plus error, where you just read directly where it intersects. So if it's on the other side, then if it's, say, like this, that, okay.
Could you move the paper up?
Yeah. So, right.
Thank you.
So you have like that. Then if this lines up like that, then what that's telling you is that that is a plus 0.03. And so, but you're correct, and I apologize for that for your mistake. So in this case, what you would do is you would take whatever your final reading was. Let's say it's 10.1. Then you would subtract the negative 0.03, and it would be 10.13. That would be your final reading. Whereas this one below would be, instead of 10.1, it would be minus 0.03, which would be 10.07. Okay. Any questions on that? Sorry for that convoluted thing. I guess that in zero error isn't something, this isn't something we would have gone over in lab normally. So I added it there just because it's something you may see depending on how old a caliper you have. But with modern digital calipers, usually you can just auto zero them and it doesn't become an issue. Okay. Any questions on that? We all clear now? All right, I'll take your silence as a positive thing. Okay, so the last thing I just want to go real quickly was the Thermocouple Lab. We'll talk more about it in detail next week, but the Thermocouple Lab, essentially what it states is that you're going to be given a set of data, and I haven't posted all the information on it yet, but you'll be given the data for it, and this is what the page will look like. You'll have the actual Thermocouple Lab you'll be able to download. You'll have a short video that shows the actual experiment process, and then you'll have a data file which you'll be given, and then you'll have a lab and a grading rubric. And so it'll tell you essentially what I want to see in the report and how I'll grade the report. And so that'll be your first major report. That'll be worth 125 points. And so that one you'll have a couple of weeks to do, and then it'll be due. So, all right. So that gives you an idea of what we'll be doing over the next couple of weeks. I know you guys have other fish to fry. So if there are any questions about anything, or is everyone doing okay so far? I'll speak it. Go ahead.
I have a question related to the Sig Fig assignment.
Sure.
So it's specifically with problem 6. It says to restate the following measurements in the correct form, but I was having trouble finding when reading through the stuff for the lab what they meant by correct form. And I was wondering if you could clarify that.
So is this the one that number 6? I don't have number 6 in front of me. Was that the one that has the plus or minus at the end? Right?
Yeah.
Oh,
it has like 21.32 plus or minus 1.
Oh, yeah. Let me explain that. So the way that works is, let me put the camera back. So the way that works is if you have, like, let's say you have a number like 41.67145, and then it's like, say, plus or minus 0.16, let's just say 0167. All right. So the rule is that what you do first off is you look at your uncertainty, and your uncertainty should be just 2 sig figs. So what you'll do is you'll change this to 0.17, okay? And then you'll look at your answer, and it makes sense that if you only have an uncertainty to 17, then all these digits out here are kind of meaningless. So what you'll do is you'll match the number of decimals to that. So basically you cross that off, and so your final answer would be 41.67 plus or minus 0.17. And that would be considered the proper form. Now, one thing is it's not an absolute with these. There is one question on there that has like 1.5 plus or minus something like 1, I think, and 1.1 or something. I think it's something like that. And so a problem like this, it doesn't make a lot of sense to, because this uncertainty is so much bigger, or such a big portion of that in this case, I would say that making this 1.5, plus or minus 1 is probably a better way to do it than making it 2.0 plus or minus 1. So again, some of them are judgment calls. Some of them are just what makes reasonable sense based on the relative magnitude of the uncertainty to the relative magnitude of the number you're reading.
Okay, that makes sense. Thank you.
Sure.
How did you know that the first one was supposed to be 2 sig figs?
Oh, so that's the rule that we're employing, is we're just saying that take your um, uh, uncertainty and limit it to 2 sig figs.
Okay.
And once you do that, then just match the number of decimals to this, to the primary, to the actual reading.
Wait, can you actually explain the 1.5 example one more time?
So the 1.5, what I was saying is that with the 1.5, if you have 1.5 and it's a plus or minus 1, actually, that's probably better is let's just look at the actual one that you guys have. That'll make more sense.
Yeah, it's problem 6, letter C.
Yeah. What does that actually say? Because I don't have it in front of me. What is it?
It's 1.5176 plus or minus 1.
Yeah, thank you. So if you have something like this, then you have, this is just 1 sig fig, right? And so you want to match the number. So if you have more than 2 sig figs, you want to reduce it to 2 at the most. But the other rule is you want to match the sig figs from the uncertainty to the sig figs of the number. So if you were really being retentive in this one, you'd say 2 plus or minus 1. But because 1 is such a big part, 1 and 1.5, that's such a large part of that, it doesn't make a lot of sense to round it up, because it really changes the fundamental number. So in that case, 1.5 plus or minus 1 would be a better answer. Now you ask, well, how do you know that? And again, it's something that I would say is a judgment call. Like this one up here, 41.6, and this is, literally 0.16 is really small, 167 thousandths is a much smaller number compared to the bulk. Whereas this uncertainty here is what, 66% of the primary number. So they are a little weird, but if you do, in some of the, I would say read it, and those are rules. But the takeaway too with the sig figs is that you notice that they only really count for when we're dealing with multiplication, division, subtraction, and add. You don't. So if you had, say, like the tangent of 45.167 degrees, there's no sig fig rule on that. So for example, once you do that in your calculator, you probably get 1.0 something, right? Because 45 is 1. But if it goes off to, like, say 10 decimal places in your calculator, where do you cut it off at? And so that's a good question, because does that then become a definition? Because what is that? It's a ratio of the opposite of the adjacent, but is it a definition? We know that if we're dealing with pi, it's 3.1415, and then that's all as far as I would use it. I just write it out, but it's a definition, so it has an infinite number of sig figs. So I think some of it is you have to look at it as, how is it going to affect your end result? How accurate is your end result? And just use your judgment.
So we would also use 2 sig figs for the first one, where it's like 0.03461. We can just reduce that to like 0.035.
If it was 0.0, what was the number? Is 0.031?
3461. And we would just bring that down to 2 sig figs.
Yes, that's correct. It'd be 0.035. And then you'd match those number of decimal places to the original number, your measurement.
Okay.
Will the number of sig figs for the uncertainty always be 2?
Yes.
All right.
When I say yes, I would better answer is that'll be the maximum. That's typically the maximum number. So it might be 1, but if it's not, it's never more than 2 from what I've seen. But again, I don't want to make, I don't want to make any absolutes when it comes to this, because it's not something, it's not like a fundamental law that is accepted by everyone. It's just in this context, the way we're teaching it, we're kind of taking it based on textbooks that we've read in our experience, but not to say that someone else might argue otherwise. But we try to make it as practical and as logical as possible.
Can you also go over problem 4, specifically D or E?
This is on.
It's also the Sig Fig assignment.
Oh, okay.
Yeah.
Could you specifically go over E actually? Because I think that one, if we were to do following the rules, for each like operation, we would accumulate round off error. So do we just do the whole calculation and then use the term with the less or with the least sig figs in the final answer?
So D and E this is is this the 5.685 times 10 to the third and 5.6750 times 10 to the third, right?
I think you're looking at problem 5.
Oh, I'm sorry.
Yeah.
Oh, 6. I apologize.
Yes. It's all good.
6 was number which one?
Wait, I don't think we're looking
We're
at
looking at
six.
number 4.
Looking at 4, yeah.
And make sure I'm looking at this. I have so many versions and I've changed some things. So
Letter E would be like 8.624 times 1.56.
It's doing the calculations and having the answers with the appropriate number of sig figs.
yeah, and I just want to make sure I have it right. Okay, so you said problem number 4, and then it was E or D?
We could do E.
Okay, so that one was, yeah, 8.624 and then times 1.56, right? And then, so you have 32.725, and then of course that's subtracting 32.71. And so what do you get when you subtract that? You get 0.15, right? But because you never go more than the number of decimal places, so really you only have one sig fig, don't you? Because, so you see how when I subtracted, I get that, but then because you're subtracting, you never go beyond that, because this sig fig this 5 doesn't really count because you're going into the thousands place and you only go to the hundreds here. So the way I do this one is I go ahead and I multiply 8.624 times 1.56, and then I divide it by 0.015. And what do you get for an answer then?
Wait, can you explain why it's 0.015 with, you said it's 1 sig fig?
Yeah, so if I take 32.725 and it's 32.71, right? And I just subtracted that, right? I get 0.105, right? So this is basically this divided by 0.015, right? That's what that is, that part. But because remember when you're doing subtraction, you have to line up the number of, the appropriate number of values after the decimal, right? And so it's just like if you had 6.1 and then you had 5.00078, right? You would cut it off at anything past that in your answer. Same thing here, we cut off anything past that. Now, it doesn't mean we don't use that when we do our calculation. It just means in our final answer, we have to look at how many sig figs. Here we have 4, here we have 3, here we have 1. And so that's the one that dominates. And so that's what you end up in your answer. So your answer, let's see. So you have 8.624, 1.56, and then so you get 800, did I do that right? Yeah, 896. So that gives you what, 900? Where the twos aren't significant. So you can write it as 9 times 10 to the third. Although in Canvas, or not, yeah, actually it's 9, it's 9, did I do it at 0.01? Maybe I put 0.15 in there. Sorry, I was just doing this really quick. 8.624 times 1.56, and then divided by 0.015. Yeah, 896. Yeah, so 9 times.
Can't see the bottom of your paper.
Yeah, so 9 times 10 to the 2, it's 900. So, but Canvas won't do it, so you just put in 900 as your answer, and that would be what would be correct. The assumption is that these aren't significant.
So just to clarify, the way we're supposed to do this is to figure out what the addition comes out to be, and then the number of significant figures in that, and then
Well,
compare that to the rest of the multiplication.
so you compare, so if you think of E, you have 8.624, that has 4 sig figs. If you have 0.56, that has 3. So if you were just multiplying those two numbers together, whatever you got, you'd reduce to 3 sig figs, correct?
Right.
So then you look at the fact that you divided it by that 32.725 minus 32.71. That gives you 0.015. So technically that's 2 sig figs, but in that little bracket, you can't have the 5 count because it's beyond the both numbers don't have a thousandths place. The 32.71 has a hundredths place. So you have to cut it off at the hundredths place. And that's why you end up making it be just 1 sig fig, which then subsequently pans out to be 900 when you figure it out, because the actual answer is 896.96.
Yeah. So even though it is even though the 0.015 it's technically 1 sig fig, we don't divide by 0.02, right? We don't round that yet. We do the
No, you don't round it yet. You just keep the 0.015 into the calculation, but you only had 1 true sig fig in that calculation.
Okay.
The correct one would be 900.
I think I get it.
And so, like, for example, if you look at C, where it says 7.319 times pi squared, since pi has an infinite number of decimal places, then you end up with 4 sig figs in the answer, because the 7.319 is 4 sig figs, and pi has an infinite, so 4 is obviously the lesser of the two. And in B, you just have 2 sig figs because of 0.056. In A, you have 3 sig figs. Does that make sense?
Yeah, I think I get it. Thank you.
Okay. So other than my snafu with the caliper, and I apologize for that. I think I was thinking backwards. My original premise was correct. It's just back down here, as you guys said, it's you subtract it, you don't add it. I don't know if there's a major brain fart, but did we understand that? Do we understand the calipers and how to do those? Have any questions on that? All right, I'll assume by the overwhelming cacophony of sound that is true. All right, anything else? Any other questions on anything?
One thing I noticed when I did the Canvas quiz for the calipers was that any zeros, so if the number was after a decimal point, if we put remaining zeros to sort of try to show the significant figures, Canvas would just get rid of them. Is that a problem? Or how
No,
should we?
It's not. Canvas will. And so to address that, I thought I'd save time by putting in the answer on Canvas, but I didn't. I end up having to hand grade everything anyway. So I will just go back through all of the answers and make sure that they're correct. So yeah, just put in what you think is correct. And if Canvas does something, don't worry about it.
Okay, cool. Thank you.
Sure. Okay, well, if there's no other questions, you guys have a good rest of your day, and thanks for dropping in. I'll update you guys on Canvas as to anything else that's coming up, but otherwise, just get these 2 assignments done by next Wednesday, and then we'll start diving into the Thermocouple Lab. All right?
Thank you.
Okay,
Well,
guys,
future,
take care. Have a good rest of
thank
your day. All right,
Thank you.
bye-bye.
Have a good day.
You too.
Thanks,
Bye-bye.
Professor.
I have a
Thank you.
question. Will future meetings also be at this time?
Yeah, if we have them, they'll be. This is the only time I could think of that would work because it's UU hour, and I don't know the least likely time that people will have classes.
All right.
Wait,
So-
are you gonna email us before every time we have a class? Is that
Yeah,
how it's gonna
yeah.
go?
If
Okay.
there's exactly, yeah, I'll remind you guys if there's something because I don't know if we'll meet every week. It just depends. So, but if we do, I'll definitely let you know. All right.
Okay, sounds
Thank
good.
you.
Thanks again.